Hi, everybody. We're going to go through an R script that was assignment 3's script, and let's get right to it. In this script, we are evaluating a data set that we imagine consisting of a group of entities that we're observing two times, so two time periods, a pre-time period and a post-time period. And between those two time periods, some intervention, some treatment, some policy change has happened, and it's happened for some of the entities, but not for others. So we might imagine, for example, that we were observing entities in the pre-period, and then a government changed policies for uh, half of the entities, or had a program that intervened for half of the entities, but the other entities didn't have this policy or program or intervention. And then we observe them all in the period after the intervention takes place. So that's the classic setup for a difference in difference framing. Now, the intervention might be a randomized control trial, in which case we allocate the treatment randomly, but it might not be a randomized control trial. It might be that there was some reason that government only had the policy happening for some of the countries or entities, or counties, or cities, or states, or persons, whatever the entity of observation is. So the difference in difference framework can be applied both to randomized control trials or to interventions that are maybe more like natural experiments. There'll be more credibility, of course, with the difference in difference framework if it is a randomized control trial, because then the entities that experience the intervention compared with the sort of control group entities are very similar. If uh, it isn't a randomized control trial, but there's some policy applied, or some entities have policies, programs, experiences that are different from the others, we'd worry that maybe the two entities were different beforehand, and so differences that we observe afterwards can't just be attributed to this intervention or change or policy or program, but might be due to something else that was going on in these entities that we aren't observing. And so we would wrongly be attributing the effects of this change that we think we understand to that change, when maybe it's actually due to something else that was going on that was also changing for the what we're calling the treatment group and the control group. So there'll be varied degrees of credibility about this estimation strategy, this identification strategy, the difference in difference, depending on what our underlying um, uh, assumptions are about whether this treatment is random or whether it's a natural experiment and somewhat random, or whether it might indeed be due to some underlying differences in the groups. So let's go ahead and look at how we would analyze this. First, as usual, we'll clear um, the working space. We'll load some libraries here, the usual libraries. We'll turn off scientific notation and load our correct standard errors function. We're going to set a working directory. You're going to set it to whatever you have. Now, those of you in the class, you know that you have the CSV file, so you'll read that in. I'm going to create it with the original um, way that I created this data set. So there's the data set showing up. This is a simulated data set, not a real data set. So now we have our data frame. Let's take a quick look at it. We have three variables, covariates, x1, x2, x3. We have a variable for whether the entity is in the treatment group or not. And we have a variable for whether we're observing the entity, which has an identification number 101. So here's 101, observed two times. Post equals 0, post equals 1. 102, observed two times, post equals 0, post equals 1. Entity 103, observed two times, 0, 1. Identity 4, observed two times, 0 or 1. Now this x3 is some other dummy variable, right, that takes on value 1. And the assumption here is this dummy variable, whatever the characteristic is of the entity, isn't changing from 0 to 1. So it may be that if we're observing a county, then maybe this county's on the West Coast. So 1 means it's in the West Coast. If these are households that we're observing, then maybe X3 is whether the household is headed by a woman. So it's a female-headed household. So that would be 1, 0. And that typically would not change between our pre and post period. Notice we only need 1 variable for the post period because a 0 for post means it's the pre-period. So we don't have to have a separate variable for pre, whether it's the before time period, because that would just be the reverse of the post. It would be 1, 0, 1, 0, 1, 0, 1, 0. 1 is just a linear combination of the others. And then we have our outcome variable y. So those are our variables here. The first thing we're going to do is follow the lead of one of the students who submitted the assignment groups, and we'll change the names of the variables. So I made a little modification here. We're going to make that third x3 be a dummy variable for landlocked. X2 is the income of the entity. These are countries according to this group. The female share in parliament. The outcome here was the educational attainment of women. And the explanatory sort of change was did the country join the World Trade Organization? So we imagined some period before the World Trade Organization was established. I think World Trade Organization is 1984. So we imagine we're observing all the countries before the World Trade Organization is established. Then we're observing the countries after the World Trade Organization is established. Some of the countries join the World Trade Organization, some don't. In reality, right, many countries of the world joined, so this is a little unrealistic in that so many countries of the world joined. But we can imagine maybe there wasn't that many joining. So we have some kind of group that didn't join, group that did join, and they're reasonably similar. So the group that did join liberalized their trade. The World Trade Organization joining it meant you had a more liberal trade policy, more open to international trade. So that's the idea here, and maybe that generated greater or lower female education attainment is the variable that's our outcome variable. Again, the words here don't matter so much. It's a generic data set simulated, so we don't want to read too much into what we estimate. Just make sure that we're estimating it the right way for whatever the data would be. So usually, the first thing we want to do is do a table of descriptive statistics, and this is all 300 observations. But remember that some of the observations are before, some of them are after. So rather than having WTO equals 1 and WTO equals 0, maybe we want to do the subset by whether it's the pre-period or the post-period. So this would be pre and this would be post. So this would be countries before the WTO. And before the WTO. And the next one would be countries after. But of course, we could do it the way they did it, which was the countries that eventually joined the WTO. But then we're calculating the average of the pre and post periods, and we might not want to do that. Anyway, whichever way you do it, both ways are reasonably fine, and it's up to you to look at the tables and see, well, what does it tell us? And the first thing we notice here, right, is that this is the post period, right? And the education attainment is higher in the, lower, I'm sorry, in the post period than in the pre period. So rather unrealistic, of course, right, that education would go down over time to education attainment. So it is for the United States now, so maybe it's not so unrealistic, right? We can also do a nice table with this code here of the means pre and post. So that summarizes, right, very nicely. So we have we're grouping by the post period and whether you join the WTO or not. So this is whether you join the WTO or not, and this is before and after. So we see that both of them went down from 281 to 265, from 287 to 276, but the countries that didn't join the WTO went down by more, went down by 16. This only went down by 11 or so, right? So the difference is about 6 between the two. The difference in the differences. So let's calculate that difference in the differences and let's see what we get. So we get 5.19, 5.2 basically is the difference in the differences, right? So this, you can read this, how we calculated. We created a data frame XX, group by WTO. All right, we're basically just doing what we did here, but now we're calling the table something so that then we can calculate manually the difference in the difference. So if we look at XX here, we see, okay, here's the four numbers and we want to calculate the difference in the difference of these four numbers. Your job is to go through this carefully and make sure you understand it. And while you're reading the book, right, alongside. Here's another way. This group had an interesting way to calculate the difference in differences, gives us the exact same number, 5.2. You might find this way a little more easy to follow. It uses piping a little bit more. This way is a little bit more base R. So we're calculating the mean conditional on, in the brackets is the condition, that post WTO equals 1 and WTO equals 1. Then here post WTO equals 1 and WTO equals 0. Then here post WTO equals 0 and WTO equals 1, and so on. So we're doing exactly the same thing, just two different ways to do it. And now we can do a nice, this group had a nice visualization of the difference, right? So we have the before difference, the pre-difference, and then the post-difference. So I might have the group here by, I wonder if we put in here, let's see, the x-axis, if we put this as a factor variable, I think that might be nice. Let's see if that works. Yeah, a little, well, no, now our graph went out of control here, so I won't do that. There's ways to make this graph a little better. One way would be to have the theme be black and white or classic. So we go with theme classic. I think that's gonna work. And let's see. Yeah, looks a little nicer, right? We don't need all those gray grid lines. They're not really doing very much there. Yeah, so that gives us. I like how this group had this line segment that is a dotted line that's extending the sort of conceptually what would have happened if there wasn't a difference in the differences. Now we have some other visualizations. Let's take a look at them. So this is more like a kind of a, I guess those are the standard errors, right, of the means. So we've got the standard errors of the mean. So again, this is something you might want to look at. Can I do this? Can I replicate it? Can I understand how it works? Notice the facet wrap here, which makes two graphs, one for the group that's in the WTO and one for not in the WTO. So that's this. You can also, the more common syntax is just to have the tilde mark. Let's make sure that that works here. Yeah, we get the same thing. And let's see what else we can do here. So this was another graph that the group had, box plots now. I think it's box plots. Where's our ggplot? Yeah, so we have a geom box plot. The legend might be better off if it were underneath. So let's see if we can put that, I think it's theme underscore legend. I think that's, let's see if we highlight it, do we get anything? No. Let's see, maybe it's theme dot legend. Let's try underscore. Theme legend position equals maybe bottom. I think that's the syntax. And that's not the syntax. So maybe it's, well, the way to find that is to Google legend position and then adapt it, but I'm not going to do that now. All right, let's run some regressions. So notice we got regressions with increasing numbers of correlates, of covariates, of control variables. So first, just the very simple diff and diff regression. Then we add this control variable, then two control variables, and finally all three control variables. And we run the table. run the whole regression and generate a table of regression results. Notice how we have a title, we have some notes here at the bottom. Our variable of interest is the interaction of the treatment variable with the post variable. So that's how we calculate the impact of this intervention or policy or treatment, is that coefficient. And again, you need to read the textbook to see the table that we have there. Yeah. So that's the mechanics of using R to estimate these things. I hope that's helpful.